Hey, Steve.
Hey, how's it going?
Good. So today we're going to talk about something you and I talk about constantly. The only missing ingredient here is we're not drinking beer. Usually we are. But AI, and particularly AI for what we do in smart buildings, smart workplace, smart campus, smart physical space. Let me start off by just saying the three areas I think we're focusing on, and maybe you can add to this and what you're doing, because I feel like every day we sort of go off and learn about AI on our own and then come back together with ideas, and it's just moving so quickly that it's hard to keep up with. So firstly, predictive analytics. So that's an area I'm really interested in because it can be the input for automation based on what's going to happen, and we can help train what's going to happen from our historic data we're connected to. So that's one area we can discuss, building models around that. The second area is user experience based, so replacing forms and buttons with a natural language user interface. And third is computer vision. So detecting what's going on in the physical space through AI-based vision.
Yeah.
Which of those are most interesting to you?
I mean, probably the LLMs or the computer vision.
Yeah.
I'd say the predictive models based on historic data is almost doesn't require much AI, really.
Yeah.
It's mostly just drawing a graph and looking at where that's going to go, or historically, I don't know, similarities in historic data.
And so language is sort of important here. Like, is that more, instead of AI, should we say machine learning in that scenario?
No. So the machine learning part happens before we get the large language model.
Yeah.
So the large language model is effectively an AI trained on all of humanity's information.
Yeah.
Or to the best ability of the people training them. And it's effectively a model that just looks at text and then generates. I mean, it's very complicated.
Yeah.
The actual training methods, but yeah, it's too hard to sort of explain. But once you've got that large language model, it feels like it's learning or doing something based on your input. But really it's sort of just predicting the next word, but taking in the context of everything you've been talking with it about.
Yeah.
And which is sort of how your brain would work. You've got context of everything you've learnt historically, which is sort of the base model if you're looking at an LLM. And then you've got your current conversation.
Yeah.
And the LLM is effectively just looking at the conversation, taking into account its historic learning, and then deciding what to say next.
And I guess it's similar to the way we have our own internal voice as well, right? Like converting the world around us into our thoughts, which is language. So
yeah.
So it's a similar process of, I'm thinking about this table. Those are words I put together to describe what I'm looking at, in the same way that these LLMs can do that with their input and their training.
Yeah. And I mean, it is emulating the human brain to the best of our ability.
Yeah.
So it is a neural network.
And to the best of our knowledge, we don't know the human brain very well.
Yeah, no, I know.
Perhaps we'll learn about the human brain, ironically, from the AI.
Oh yeah, we definitely are.
Yeah.
But yeah, so it's just interesting that we got to this point where we looked at, if we add more neurons to a model, because if you look at like computer vision, it's usually smaller models.
Yeah.
And they're just highly trained to do one sort of task.
Yeah.
And the aim with these LLMs was general artificial intelligence, so able to do anything. And they just kept adding neurons, and then suddenly it got to a point where it started looking intelligent, like a human.
Yeah.
So we know now that more neurons means more intelligence.
Yeah.
And that's sort of proven.
Yeah. Have we been training these models without realizing it with these are you a robot tests where it says choose the traffic lights or choose the bikes?
Yeah, we have. So that's just computer vision there.
Yeah.
So that'll all feed back into, say, Google's self-driving car.
Yeah.
Or just Google Maps, trying to work out like what the speed is in this area and things like that.
I find it funny, often I've seen stand-up comedians do bits on that, like how does it know we're a robot or not based on choosing the traffic lights?
Yeah.
But it's like, when you think about it, it's so obvious that it's not really about us proving we're a robot or not. It's about us. They're looking for an opportunity for us to train their models.
Yeah.
All these users that have to do that constantly, training their computer vision.
Yeah.
So let's talk about computer vision. You're doing an interesting side project, which in turn is like helping train a model that we're using commercially. Can you talk about that?
Yeah. So I guess the core of our computer vision project is to build a platform for running computer vision models. And we're using the Google's sort of standard deployment model. And the platform that we're building, because it's less about us training it. Of course, we'll be doing training for specific use cases.
Yeah.
Like, I don't know, clutter in a kitchen, or I don't know if you're doing some sort of smart city thing, could be potholes or things like that. But the platform itself is more a generic way of just deploying computer vision models into the world and getting data back.
Yeah.
So taking any camera stream and then applying computer vision to it, AI detection to it, and being able to analyze that and perform actions automatically based on what the computer's seeing. And we could, say, feed some of this stuff back into an LLM because they're multimodal.
Mm-hmm.
But obviously computer vision, smaller models, so very fast. LLM, massive model, quite slow. But you can say, I'm interested in this thing. You can do a bunch of computer vision AI on it.
To detect the thing.
Then pass it to the LLM and say, I think this is this. I think it's this thing. This is the other sensor data that we've got. Is this an issue?
Yeah.
And the LLM can then make a smart decision about whether it should email us or, perform some other action.
Yeah, or provide more context around it. So I guess the simple way of thinking about that is the computer vision can be basic input.
Yeah, exactly.
So instead of a human saying, "Oh, there's 5 people there," you can see, "Oh, I can recognize 5 people, and 3 of them have backpacks," and that simple identification that then can either go to automation directly or log that as analytics, or in the future, be multimodal with other AI LLMs taking that further.
Yeah.
But you didn't talk about your side project, so it's an interesting one with the at your property in Mudgee.
Yeah. So this is more just motivation to work on the platform, because the platform's quite complicated and involved. Like, we're at a stage now where it's fun to work on again.
Yeah.
So the first sort of steps were, how can we make these models work and get data out of them? But then we had to sort of genericify everything so that so all the data comes out in a sort of standard format that makes it easy to parse. But my personal project is there's 2 actually. So I've got a chicken door and a pest management pistol.
Yeah.
And so this is just a poison gun, effectively. It just shoots water laced with fox poison. Obviously, it's not doing that right now. So I'm actually working with my brother, who is in environmental management, works for the Western Australian government.
Yeah.
So he's currently doing the I can't remember what it's called. I don't know. It's not moral. It's
the ethical,
the ethics.
the ethical way of dealing with pests, which are living creatures, right?
Yeah. So
does that even come down to like what poison is used, or like if a poison is used?
It's not so much that. It's about working out like what is the false positive rate and things like that.
Okay.
So if we run a trial, what's the impact on the environment and the animals that live there currently?
Yep.
Obviously, the trial would just be pure water.
Yeah.
Or not shoot anything at all. Depends what the ethics board deems useful. And
I guess you could then collect the data and like simulate the action and say, here's the false positives over that time period.
So that's the idea.
Yeah.
But you still need ethics approval. And the ethics boards are very stringent. I'm not sure. I mean, my wife's a doctor, so she has to deal with ethics boards all the time. That's more a human level. And the thing she's not allowed to do is just weird.
Okay.
Like, I don't know, she's doing blood analysis on I don't know, pregnant people if they have a bit of bleeding.
Yep.
And just showing pictures to doctors to try and work out whether they can look at the picture and guess the correct amount of blood, because doctors are bad, it turns out, at estimating how much blood loss has occurred.
Based on?
Just based on looking at
the volume that they perceive.
In the underwear or whatever it is. And she wasn't allowed, I think she wasn't allowed to show nurses. She's not allowed to talk to patients. She's can't put signs up informing people, because, people would get upset by blood and things.
Yeah, so it's too icky for some people.
I don't know exactly all the details, but
it's an interesting tangent, because like ethics and AI are hand-in-hand conversation. I've never thought of it by extension to the actions that you're performing. It's not about like, we're not talking here about privacy ethics with the AI data storage, retention, etc. It's, well, what do we do if there's false positives in this scenario where I'm trying to deal with foxes eating my chickens, but what if, the neighbor's cat comes in, or I don't know, whatever ethical situations they're interested in on these boards, which we don't know.
Well, we sort of do, because there's a product out there called the Felixer, which works in a very different way to what I'm working on. And it uses lasers and just measures the height of the animals.
Okay.
And it definitely has a somewhat significant false positive rate, but obviously it's wiping out the pest animals much faster than it's killing the non-target animals.
Yes.
So it's got a net positive, but that would have all had to have gone past ethics boards. And there's a bunch of stuff that I'm looking at doing, which is like, working hours. So what hours say pets unlikely to be out? Not that it matters much. It's all going to be in the countryside where, kilometers away from anyone's pets. But on the off chance they get out
and find their way in your trap, it's very unlikely.
But we can do things like beacons. So provide the neighbors with beacons they can put on their pet's collar. And if it detects a beacon nearby, it just shuts down. So there's lots of these other inputs that we can use. So only run between midnight and 4 a.m. Detect beacons. I plan to use, so a lot of the stuff that's out there in the real world, the Felixer stuff, is I'm not sure how they do remote management, or if they do remote management, but there's new technologies like Wi-Fi Halo, which can do 1 kilometer or more in terms of Wi-Fi range. So I can get live video, live details on, say, capacity of the poison, statistics on what it's been doing, and should be able to react faster.
Yeah, which is interesting because then it has this IoT element as well, which, just bringing this transferable back to our day jobs. Of AI recognizing objects and then performing automation. That's essentially what you're describing. But then you can have these. I assume it's like a low energy wireless that can, because it's low energy, it can broadcast further, but not as much data, I imagine.
Yeah,
because the frequency isn't as high.
It's actually, it runs on the same frequency as LoRaWAN, which is just a public frequency that anyone can use. But it uses, so LoRaWAN's quite old, and the Wi-Fi body took all the stuff they've learned about signals and cramming information in and error correction and all that sort of stuff that makes, say, Wi-Fi 7 really good.
Yeah.
And they've put it into this Wi-Fi Halo technology. So the design of it was to be able to push 1080p video.
Okay.
I think at least 30 frames. But yeah, full 1080p video.
Yeah, that's pretty amazing compared to the old standard.
Yeah.
Because you're compromising with lower frequency, you're compromising data and size of packets and things. But yeah, that's an interesting way to get into computer vision, and it sounds more complex than a lot of the requirements that come up in our projects, right? Where we're just detecting people. Rough age range, people counting,
triggering signage or something.
Yeah, is there a dirty plate or not?
Yeah,
we're not shooting anyone with poison.
Yeah. Which is why we don't have to go through ethics boards.
Yeah, maybe there's a scenario where we are shooting people with poison. All of these things are highly transferable as Placeworks being a platform. But we'll try to avoid ethics boards as much as we can.
Yeah, exactly.
What other areas of AI are you interested in? What else are you working on? I mean, you did a demo last week on chat-based user experiences. We're just scratching the surface with that.
So that's sort of the most powerful, because that, the companies behind that, OpenAI and I don't know, Facebook, if you're looking at other models. Yeah. And Hugging Face and things like that.
And just like Copilot in Microsoft leveraging OpenAI, but being so baked into all their products.
Yeah. And because it's all designed to aim towards a general artificial intelligence, it just means you can almost do anything. So anything a human could do, given enough information, the AI should be able to do, if not now, in the future.
Yep.
So in terms of automating tasks, it's pretty amazing. It's more about getting the information that we have and making it available to it in a way that you can actually action it.
Yeah.
That's the challenging bit, because it's more like a human. But if you're building a computer system, you're usually building it as a computer system. So if I want to talk to a database and store data, that data doesn't look good. It looks like raw data in a database. And an LLM has just as much trouble looking at that data as we do.
Yeah.
So you've got to make it look nice. You're going to explain it.
Yeah, it's interesting, isn't it? It's like we're designing for an end user that's an AI, but there are some surprising differences. It was eye-opening to me when you did a demo just for me once, and it was showing what it was doing. It was showing it's working out as it went along, and it tried a few different things. It didn't work, and then it tried other things. So it's not just taking our workplace app and clicking in the buttons in the background. It's actually making API calls and finding unique ways to get to the end result, which is it's almost like it's thinking about it, which is a weird thing to say.
It sort of is.
Yeah.
And it's very human. It's just like a human that's running really fast. Because a human could do all this. It just take ages to type out the JSON or whatever. And it does it extremely quickly compared to an actual human.
Yeah.
But it's doing a human-like task. And if you asked a human to do it manually, they'd do it that way.
Even the same way, the feedback it gives you in real time as it's doing it is the same sort of feedback. If you gave me a task I've never done before, I'd probably be talking out loud about what I'm doing. I'd be like, oh, I'm just trying to find where the room booking form is and seeing what is currently grayed out. So maybe I have to fill in a few mandatory fields here. And, oh, yep, now it's available to me. I can go on to the next step and add some catering. And
and I got this error and it's with this field. So obviously I got to change this.
Yeah, and just going through and correcting your own mistakes, because now I've done that once. I know that I'm not going to do it that way next time. That's pretty interesting, and I feel like it's like one of those technologies we're going to take for granted so quickly. Like it's novel and interesting to us now in terms of the user interface, but as soon as everyone has it, they're just going to be like, expect it to work seamlessly every time. And I think that could be a challenge, because it's still like a bit, different. It's a different way of interacting with technology that.
Well, we sort of have it. Like, how frustrating is using like Alexa or Siri now?
It's insane.
You're like, I can ask this LLM anything on my computer that I've been programming to interact with workplace stuff or whatnot. Like, extremely complicated things for a computer to do. And then you like play some music on my kitchen speaker, and it's like, I don't know, I said it the wrong way around. In the kitchen, play music.
It happens to me every day. I have what I call dance party time with my 2-year-old. So I go home and when I get home, we have a dance party, which means I'm just always asking for different songs. And it fails like at least half the time I'm asking.
Or it finds a weird version of the song.
Like a cover version of a Michael Jackson song, and just like, this isn't the right thing, because someone's hacked the system to like be like, oh, I'm the response you get when you ask for Michael Jackson. I'm excited about the user interfaces, sort of the area I've always been really interested in, and an area that from day one we've been discussing. How do we remove the user interface? Like, let's not have apps and interfaces if we don't need them. I think this natural language is a first step, and then and related to that is voice control. And I think once we get the natural language working really seamlessly, we're definitely going to move on to voice control integration.
Which is effectively just LLM, just converting that voice into text.
And like interfaces to it, like having when is it listening, and how do we trigger the listening function, and can we have situations in some rooms it's listening at the right time, and lots of little things like, which I love, because it's like audio design, and that's sort of a hobby of mine.
I mean, if money is no cost, you could have it listening at all times. But obviously it's got to do all that processing to see if you're talking to it or about something that it works with.
And getting those, like, if it's listening at all times and it can control things by going back into PlaceOS drivers and APIs, we also have that opportunity to tie in those real world features that people like in video conferencing, like the transcribing and the meeting summaries. Like, we could have that in real life if we have this way of listening all the time. And I think this is, we could talk about how creepy this could be or the privacy concerns, but ignoring those for a minute, like the functionality that could create is pretty interesting.
And a lot of it could run on your own device, I guess. Because I know the smaller models, which aren't quite as good as ChatGPT, that are open source as well. People have running on their own hardware. I know Microsoft released something the other day, which is something like 4 times smaller than, say, Facebook's model, and roughly equivalent in terms of performance. So that's a pretty big jump, because that means it'll run 4 times faster on your local hardware. And so that means less expensive hardware. So a couple of years, that'll probably be a tablet or something sitting in the meeting room.
Exactly. This exponential growth, both the engineering of the models requiring less space and the chip engineering. And,
everything going faster, the models getting smaller, but just as effective. And then you were talking about good, interesting interfaces. I know Google faked it, which their latest demo, but the interface looked nice, and I'm sure it's something you could create. Like, it looked.
You're talking about the one where they're drawing a cat or something, or a duck. So that's a fake demo, but
they faked it
based on real technology.
So they just took pictures, so they obviously had him do the video, and then they'd take a snapshot, pause
Got it.
get the AI to do it with just uploading the image. And then they even typed out the transcript. So there was no voice to text.
Yeah.
Or text to voice, I don't think.
Okay.
I'm not sure. But yeah, completely fake demo. And I don't know about the perspective. That sort of top-down camera view doesn't seem realistic.
Yes.
But
the only time I've seen that is in lecture theaters with document cameras.
Yeah, exactly.
So maybe in the lecture theater it could be handy.
Yeah. That's a good point. But sort of an interesting interface where you're interacting over a video feed.
Yeah.
And it could be there's a new pin. I can't remember what the company's called, but they want to replace the smartphone with a little projector pin thing that sits on your lapel.
Yeah, and then you interact with your hands.
Yeah.
And we're already seeing that with Apple Watch with the pinch action.
Yeah.
Like if we start to get to the ability where we don't need the phone and we're just using actions and projections and holograms.
And I'm sure watch and glasses will probably replace the phone faster than a pin, but
yes,
that's just my opinion.
Yeah. But this is all just like, it's an interesting thing to sort of wrap this up on, that all of this technology is converging. It's not one technology. It's we spoke about two separate things initially, computer vision and LLMs.
Yeah.
And how they could feed each other, but
and also the data. So when you're looking at the historic data, you would be converting that into something nice.
Yeah.
So you'd want to be not using AI, just taking the data, creating graphs or reports, and feeding that into an LLM.
Yeah.
Instead of feeding it the raw data.
Got it. Yeah. And then all of this changes the way we interact with technology immediately. But then as these new interactions are invented on different, augmented devices and away from our phones, we're finally free of our phones. Finally free of touch panels and GUIs and, just stuff that was always in the way of a good user experience. Why we started the company, because you had all these touch panels everywhere and all these apps everywhere. Now, we're getting to a point where it's much more natural to interact with technology. So that's exciting, because we've been saying this for a long time, and now we have an industry supporting us to achieve these goals in our niche of smart buildings.
Yeah, it's really cool.
Okay, cool.